All right, example 4, a rectangular box has the following properties. The sum of its edges is 24 feet. Adding together the area of each of its faces gives a total of 22 square feet. Its height is twice its width, and then we're asked to find out what is its volume. So the first thing to do is we want to get a sense of what are we looking at. So let's draw a quick picture. So if we've got a box, right, some box. Okay, so it has three things to it, right? Length, width, and height. So we can see that we've got, what's its length? What is its width? And what is its height? Great. So with that in mind, let's start trying to figure out how do these properties turn into math. The sum of its edges is 24 feet. The sum of its edges. Now, technically, we don't really know, are they saying just one of its edges each time, or are they saying all of its edges? So sometimes you wind up seeing things that are a little bit confusing in math. If you saw this on a test, it'd probably be a good idea to ask your teacher, because you're not sure, does that mean h plus w plus l, or does that mean each edge of the box all added together? So let's go with the sum of every edge. Let's say that's what it means. But notice how each of its edges, the sum of its edges, well, that could be considered just be the three edges, the sort of fundamental edges, height, width, and length, but it could also be all of the times they show up on the box, right? If you've got a rectangular object, it shows up here and here and here, right? Height actually shows up 4 times because we've got each of the sort of columns that make up our box. So we've got a height here, a height here, a height here, and a height here. So we can think of it, if we're looking at every edge, as it's going to be 4 height, will be part of what's going into that. So the sum of not just its edges, but every edge is how we'll do this problem. All right, so if that's the case, this first thing is going to wind up coming out to be, so first idea will come out to be 4h plus 4w plus 4l equals 24 feet, right? So height, width, and length all combined together comes out to a total of 24 feet because the sum of every edge, every one of the edges, and each edge, height will show up 4 times. Width will show up 4 times on the box. Length will show up 4 times on the box. If you find this confusing, try just finding some rectangular object that you can look at, like pick up an actual box and count the edges. Count how many times its height shows up. Any rectangular box will be able to show you this idea if it's a little confusing. Physical things are a great way to explore stuff in math. Next up, adding together the area of each of its faces. So this one's a little bit tougher. So how many times does, let's say, like this face right here, the very front face, show up? Well, we see that height times width would be the area of that face. So height times width is going to get multiplied together. But it doesn't show up just on the front, it also shows up on the back side, right? So it's the front side, but also the back side, both sides. So it's not going to be just h times w, but 2 times h times 2hw. By that same logic, each of the side faces, so we're going to have l times h, right? Because it's h over here, so the side faces will show up twice as well. So we've got 2lh. And then finally, the top face is going to be the length times the width. So 2 length times width. And we were told that came out to be 22 square feet total. So we can find the area of each one of the faces. HW will be one of the faces, and then it doubles up each time. LH will be the area of one face. It doubles up, so on and so forth. So we've got 2HW plus 2LH plus 2LW equals 22. And then finally, we were told that the height is twice its width. So that's probably the easiest one of all. If the height is equal to twice the width, so 2 times the width. Great. At this point, how do we find volume? What's volume based on? Well, if it's a nice rectangular box, volume is just equal to all 3 of these variables multiplied together. H times L times W. Great. So that's all the steps that we need together to be able to figure out what this is going to be able to get this in a position where we can solve it. So now let's start working it out. So we've got 4L plus 4W plus 4H equals 24, 2LW plus 2WH plus 2LH equals 22, H equals 2W, and we're looking for volume, which is going to be L times W times H. Great. So I'd say the very first thing to do, let's take 4L plus 4W plus 4H. Let's make a little bit easier. Let's divide everything by 4. So we've got L plus W plus H equals 24 over 4 gets us 6. Same thing over here. Let's divide everything by 2, so that gets us LW plus WH plus LH equals 11. Great. So at this point, we can actually start figuring things out. So let's try to solve in terms of W, right? We've got W over here. H is already ready to be substituted in somewhere. So since it's connected to W, we can probably figure out W easiest from what we've got set up here. So we can plug that in over here. If H equals 2W, then we have L plus W plus what was H equal to? H was equal to 2W. So plus 2W equals 6. So L plus W plus 2W, 3W equals 6. So L equals 6 minus 3W. Now at this point, we're ready to substitute L in as well. So we've got H ready to substitute, L ready to substitute. So we can now go into our big equation, LW plus WH plus LH equals 11. So we plug in here, L is 6 minus 3W. So 6 minus 3W plus, times W plus W times H is 2W plus L is 6 minus 3W times H is 2W equals 11. 6 minus 3W times W, W distributes, so we've got 6W minus 3W squared plus W distributes onto 2W, well not distributes, but 2W squared plus 6 minus 3W times 2W, so 6 times 2W becomes 12W, minus 3W times 2W becomes minus 6W squared equals 11. Great. So let's simplify things a bit. We've got minus 3W here, plus 2W squared here, and minus 6W squared here. So minus 3W squared plus 2W squared gets us negative 1W squared. Minus 6W squared brings us to a total of negative 7W squared. Our 6W and 12W combines to plus 18W equals 11. Hey, we've got squared, we've got single degree of 1, and we've got constant. This looks like a polynomial. Let's get it into an easy to solve polynomial format. Add 7W squared to both sides, minus 18W to both sides, plus 11. So at this point, we could toss this into the quadratic formula and solve out the answers, but we might be able to get lucky. And even though it looks a little complex, we might realize, oh, hey, we can factor this, not too difficult to factor. We get lucky, we notice that it turns out pretty easy to factor. 7W and W here. We need to have minus on both of them because it comes out to be positive 11 minus 18W. We've got a 7W here, so this will be minus 1, and this will be minus 11. So 7W times W, 7W squared. 7W minus 1 minus 7W, minus 11 times W, minus 11W. So negative 7W minus 11W, negative 18W checks out. Negative 11 times negative 1 checks out positive 11. Great. Always a good idea to check when you're factoring. So we can now solve each one of these. 7W minus 11 equals 0, or W minus 1 equals 0. So we've actually got two different possible worlds. It didn't say that in the problem, but there's two different possible worlds for what the width of the box can be. It can be 11 over 7 or 1. So 11 over 7 and 1 are our two possible things. So let's call these arbitrarily. We'll make colors for these. So W equals 1. That one looks easiest to deal with first, so we'll make that the purple world. So W equals 1. If that's the case, we can figure out that H equals 2W. We plug that in. H equals 2 times 1. So we've got H is 2. And then we've also got, if it's W equals 1, we plug that into L equals 6 minus 3W. So L equals 6 minus 3 times 1. So 6 minus 3 equals 3. So we've got W equals 1, H equals 2, L equals 3 in our first world, in this purple world. Because remember, there's two possibilities for what our width could be. But if this is the case, then our volume is going to be the three of these multiplied together. So 1 times 2 times 3, which equals 6. So one possible value for our volume is going to be 6 cubic feet. That's one possible answer, right? It turns out that there's two different worlds here, so we want to check out both of them. The other one, we'll make this the green world, where the width is equal to 11 over 7. Well, if width equals 11 over 7, then we can plug that into H equals 2W. So H equals 2 times 11 over 7, which equals 22 over 7. So our height is 22 over 7 if we've got if our width is 11 over 7, then our height is 22 over 7. And then we can also figure out what is our length going to be? Length equals 6 minus 3w. W in this case is 11 over 7. So we've got 6 minus 33 over 7, which winds up simplifying out to 9 over 7. Great. So at this point, we've got width equals 11 over 7, height equals 22 over 7, and length equals 9 over 7. All of these in feet as the units. So at this point, we know that the volume is equal to each one of these multiplied together. So 11 over 7 times 22 over 7 times 9 over 7. We multiply these all out together, and it becomes 2,178 divided by 343, which is really not that easy to see what that means. So let's approximate that using a calculator, and that comes out to be 6.35. So our other possibility is the volume comes out to be 6.35 cubic feet. So it turns out that there's actually a larger possible box if we're not going with these nice friendly integer things, but we can still follow the 3 requirements. So those 3 conditions that were given to us, it turns out that there's 2 different possible boxes that actually fit those conditions, and those are the volumes. In our purple world, where our width was 1, we got 6 cubic feet, and in our green world, where our width was 11 over 7, we got 6.35 cubic feet. And if you wanted to check this, if you wanted to make sure that everything was great, a good thing to do would be to see, hey, I've got width equals 1, height equals 2, length equals 3, and then just try plugging that into each of these 3 equations that we started with and making sure, yeah, that checks out, yeah, that checks out, yeah, that checks out. Same thing over here for the 6.35 value, sorry, not the 6.35 value, not that, but the width equals 11 over 7, height equals 22 over 7, length equals 9 over 7. You can just plug that into each of these 3 equations and make sure that it checks out in each one, because if it checks out in each one, you know that is a workable answer. All right, so that finishes up our work with systems of equations of all types, and we'll see you at Educator.com later. Bye.